we now discuss a very important tool or methodology for considering the fluid flow and solving the problems, very difficult problems that otherwise cannot be solved, but they become easier to solve by using this methodology. And the consideration that we make is that of similitude, similarity, or by using the dimensions of fluid flow and its environment, where the fluid is taking place, the flow is taking place. Many problems, because as you know that one of the things we have already mentioned, that fluid is a very practical subject. It is an applied subject and used in everyday life and in many applications. Most of its problems can be solved analytically, but not all of them. Many problems cannot be solved analytically because there are difficulties that are involved. The solution of, for example, nonlinear equations becomes very difficult at times. So only specialized solution or with certain assumptions we can solve them. So to be able to solve, to be able to enhance our scope of solving the problems, we use the techniques of by considering the dimension and dimensional analysis. So that is to do with the dimensions of the fluid flow geometry, the object whereby the flow is taking place, and so on, and we learn it how to do it. So it follows that in many cases, in addition to analytical work, analytical solutions, we need to combine experimental work also. And to be able to do experimental work, to do experiments in a laboratory on a smaller scale that can be applied to real life in a larger scale. For example, considering that we want to design a ship, commercial ship, a warship, or an aeroplane, or some other machine. Now, all these machines, all these vessels, vehicles, etc., are very large and they cannot be used for experimentation on laboratory scale. So we have to use models that are on a much reduced scale, but somehow they match with the real life. How do we do that? So that is where a number of techniques have been devised by the scientists, the researchers, and very well, and they have proven to be a successful technique to be able to solve many of fluid flow problems by using this methodology. So this is what we do, that in addition to analytical solutions, we use at the laboratory scale models that are similar to the dimensions of the real life scale, and it helps in the designing, and we have seen that this can be done in a successful manner. So in fact, very few problems involving real life, well, we have mentioned this, we need the combination of the two. So we need analysis as well as experimental data, combine the two and see. But how to do it is a problem. And that problem has been met by using the similarity or similitude technique, using dimensions of the fluid flow constraints. So I have broadly explained that, and the laboratory systems are usually thought of as models and are used to study the phenomena of interest under carefully controlled conditions. And those, what are carefully controlled conditions? That is, the dimensions of our models match in a systematic manner with the real life objects and the fluid flow situation. And from these model studies, we make the real life things. And all these things happen in the real life every day. Even now, you would know the designing of an aeroplane, the designing of a car, the designing of a sports car, the bus, the designing of a ship, and so on. All these things, they are first designed in a laboratory. Several experiments are done on those design models. And then when they see that the models are working fine, then using the knowledge that one learns from the prototype models, the real life models are produced. And that is why they work so successfully. This is not a simple or easy method. Both things really have some levels of difficulty. The analytical solution as well as the working in laboratory, doing experiments, and experiments is not easy either. There are problems with experiments, problems with the equipment. The equipment is very expensive. The experiments at times can be very expensive and time consuming, whereas solving analytically at times can be time saving. But the combination of the two takes us to success. So you can see, if we have to have certain, these are examples of some of the things that we need to use in the real life: the wind turbine, the dams, the spillway, the sudden pipes, and so on. And you can see that there is a variation in the cross section of the pipe. So how to do that, and how to do it in a manner that we can use them meaningfully, successfully, and achieve the fluid flow and desired results that we want. So dimensional analysis is used to predict the physical parameters that will significantly influence phenomena under study. And similitude model and model analysis is required to be done for this. And application of knowledge on actual and prototype model is carried out, and from that the real life products are produced.